Today we're going to begin part 1 of a 3-video series reviewing the 3 units that we've just finished covering in preparation for our cumulative exam that will be coming up soon. So today we'll start with integers, and then tomorrow we'll do rational numbers, and then the day after we'll pick up the proportional relationships that we had just wrapped up. So let's get right into this. When we first started talking about integers, we had talked about what they were and how to graph them and how to find their absolute values. So a review, you do have this in your notes, in your notebook, in your notes from the beginning of the year. So we're going to review quickly. An integer is any number from the set of whole numbers and their opposites. So anything that is a whole number or a negative whole number including 0 would be considered an integer. So we have negative integers, we have positive integers, and we have 0, which is neither negative or positive. This here is called a number line, and you know you can plot integers on a number line. So if we were to write an integer for each of these situations, an average rainfall of 5 inches above normal, we know that above is a positive movement, so that would just be positive 5. And if I were to write an integer to represent a snowfall of 4 inches above normal, that would also be positive 4. It would just be an integer to represent this situation. Now on the contrary, if I was asked to write an integer to show a $5 debt, okay, so a $5 debt, that would be money that I owe, so that would be a negative integer of negative 5. Moving along with this review. We also talked about absolute value being the distance a number is from 0 on the number line. Absolute value, we had also learned, is always positive. Hopefully this is starting to come back to you. Always positive regardless. So in this example here, the absolute value of negative 5 is positive 5 because it is 5 units away from 0 on the number line. And the absolute value of positive 5 is also 5 because it's also 5 units away from 0 on the number line. So we calculate some absolute values. The absolute value of negative 4 would be, yep, that's right, it would be positive 4 because it's 4 units away from 0 on the number line. And the absolute value of negative 5, as we just solved, that would also be positive 5. Now with absolute values, you do evaluate them like parentheses. So whenever I see absolute values, I do take the absolute values of whatever's within the absolute value bars before I calculate. So in this case, the absolute value of negative 5 is positive 5, and the absolute value of 2 is 2, so 5 minus 2 is 3. That would be my answer there. Now if I'm asked to do the absolute value of negative 4 minus the absolute value of negative 3, the same process holds. The absolute value of negative 4 is 4, minus the absolute value of negative 3 is positive 3, so my answer would be 1. Alright, so after we learned about absolute values, we moved into adding integers. And here's where using that term absolute value came in very handy. So again, we know that integers have opposites, and 2 and negative 2 are called opposites because they are the same distance from 0. Not only that, but whenever I add them, I should get 0. Alright, so in the real world, we might consider hot and cold to be examples of opposites, but in math, we'd consider negative 3 and 3 to be opposites. We also call opposites additive inverses because the sum of any additive inverses is 0, meaning they undo each other. So we have that example down here. Now, when we're adding integers with the same sign, quick review here, if both numbers are positive, I keep the signs positive, add the integers, and I get 11. If both signs are negative, I add the integers, 7 and 4 in this example, but I keep the sign negative. So when we did this in class earlier in the year, I asked you guys to remember, if I have $7 and I add 4 more to it, that means I have $11. But if I owe one person $7 and then I owe them 4, that means I also owe them 11. Now when I'm adding integers with different signs, this is where it's a little bit tricky. So different signs means that I'm going to subtract the integers and take the sign of the greater absolute value. Or how you guys might think of it is take the sign of the bigger number. So in this case, if I have 9 plus negative 4 equals 5, I'm actually going to, in my mind, be doing, so I'll draw a little think bubble here, so this is what's happening in my brain. I'm doing 9 minus 4 equals 5, but I know that the absolute value of 9 is greater than the absolute value of 4, so I'm actually going to take the sign of this number, so my answer would be positive. So when I do negative 9 plus 4, same thought process is happening in my brain. I'm thinking 9 minus 4 equals 5, but since the absolute value of 9 is still greater than the absolute value of 4, I'm actually going to take the sign of this negative 9 here, so my answer is going to be negative 5. Furthermore, if I were to do this on a number line, okay, and I were to go put my 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's my negative 9. Well, if I'm going to add 4, that's going to be plus 1, 2, 3, 4, there's negative 1, negative 2, negative 3, negative 4, negative 5. So that addition of positive 4 is going to render me here at negative 5. So a few practice problems. Alright, so if I were to do negative 3 plus negative 2, I see that the signs are the same. So negative 3 plus negative 2, that's going to be negative 5. Now if I want to do negative 6 plus negative 3, same story, I see that the signs are the same. 6 and 3 make 9, but since they're both negative, my answer is going to be negative. On the contrary, if the signs are different, I see 5 plus negative 3, so I'm thinking to myself 5 minus 3 is 2, and since 5 is the greater number here, it has the greater absolute value, my answer is going to be positive. Same with 8 plus negative 7, I'm thinking to myself 8 minus 7 is equal to 1, and since 8 is greater, I'm going to take its sign. Now in this case, I'm also thinking 3 minus 2 is 1, but since negative 3 is the greater absolute value, my answer is negative. Same story here, negative 5 plus 4, I'm thinking to myself 5 minus 4 is 1, but since the 5 is the greater absolute value and it is negative, my answer is going to be negative as well. Now this is a case where I have opposites being added, but since I have 7 minus 7 in my head is 0, and they both have the same sign, it's going to have they both have different signs, they're going to have neither a positive nor a negative. It's going to be 0. Same with this one here, 5 plus negative 5. I'm going to think in my head 5 minus 5 is 0. 0 takes no sign, so it's just 0. Now, subtracting integers was quite possibly the piece of this chapter that confused us the most. Okay, so when we learn to subtract integers, we learn to add the additive inverse, or in other words, we learn to turn all subtraction problems into addition problems by adding the additive inverse. We also learned something called keep, change, change as an easier way to remember this. So when we look at this from the textbook perspective, we know that if I have p minus q, that's the same thing as adding the additive inverse of q, which would be negative q, so that would be p plus negative q. In this case, we'd have 4 minus 9 becomes 4 plus negative 9, which is negative 5. 7 minus negative 10, well, that would be 7 plus the additive inverse of negative 10, so it would just be 7 plus 10, which is 17. Now in class, we learned a little shortcut of keep, change, change. So if I bring down both of these examples, so let's start with the 4 minus 9. Using keep, change, change, I would keep the 4 the same, I would change the subtraction sign, and then change the sign of the second number. So now I do have an addition problem, but different signs, so I subtract, take the sign of the greater absolute value. Now if I look at that other example that we had been given here, where I had 7 minus negative 10, and I do the same thing and I keep, change, change, that means I'm going to keep the 7 the same, change this sign, and then change that sign. That's going to give me 7 plus 10, which is 17. So let's practice this a little. And at any time, pause the video and see if you can work ahead of me. So if I have 8 minus 13, I'm going to keep, change, change, or add the additive inverse. So that means I'm going to have 8 plus negative 13. I'm going to think to myself 13 minus 8 is 5, but since negative 13 has the greater absolute value, that is going to be negative. 2 minus 15, I'm going to add the additive inverse or keep change, so that's going to become 2 plus negative 15. So I'm going to think to myself 15 minus 2 is 13, and I'm going to take the sign of the greater absolute value. Let's try some more. Negative 10 minus 7, I'm going to turn it into an addition problem once again. It's going to become keep negative 10 plus negative 7. In this case, I'm adding same sign integers. So my answer is going to be 17, but it's going to be negative since they were both negative. Same here, I've got negative 13 minus 8, negative 13, keep, change the minus to a plus, negative 8. That's going to be 21, but it's going to be negative because both of these are negative. Alright, so now I've got 1 minus negative 2. That's going to become 1, keep, change, change. So I get 3. Okay, 12 minus negative 6, same story. It's going to become 12 plus positive 6. So I get 18. Hopefully this is coming back to you. Alright, so now I have negative 10 minus negative 7. Hey, that sounds familiar. I think we had done that earlier. So if we remember, we keep the negative 10 the same, change the subtraction to addition, change the negative 7 to a positive. So I now have negative 10 plus 7, so that means I'm going to think to myself 10 minus 7 is 3, take the sign of the greater absolute value. Same story here, keep, change, change. I'm going to think to myself 21 minus 8, and that's going to be 13, but since the negative is on the greater absolute value, my answer is negative. Alright, so on your cumulative exam, you might see a problem like this, where it tells you to evaluate x minus y if x is equal to negative 6 and y is equal to negative 5. So in this case, we simply have to substitute the values for the variable. So I'm going to substitute in, it's going to be negative 6 minus negative 5. So I have a subtraction problem, so I'm going to do the same keep, change, change. Only I'm going to do my work right on this problem, so I'm going to leave the negative 6 alone, change, and change. So negative 6 plus 5, that's going to be 6 minus 5 is 1, but since this guy has the greater absolute value, my answer is going to be negative. Now, after we learned to add and subtract, the last thing we had picked up in this chapter was the multiplication and division. And I think the rules for multiplication and division we'll find, if we remember, they're a little bit simpler. Let me cancel that. So let's get right into this. I'm going to start with the rules. Now, when you're multiplying integers with different signs, the answer is going to be negative. When you're multiplying integers with the same sign, the answer is going to be positive. So it's a pretty straightforward two-part rule. Different signs produce negative answers. Same signs produce positive answers. Now it's the same for division. Different signs produce negative answers. Same signs produce positive answers. Okay? And we have our examples here that we can look at. I had also shown you guys a way of remembering this that was kind of just fun, but if we have a negative multiplied or divided by a negative, we have a positive answer. If we have a positive multiplied or divided by a positive, we get a positive answer. Then if we have a negative multiplied or divided by a positive, we get a negative answer. And if we have a positive multiplied or divided by a negative, we get another negative answer. So I had told you in class to try to smile with your eyes closed, smile with your eyes open, both easy to do, but when one eye is closed, it wasn't as easy to do. So then we get our negative answers there. Okay, so let's review this. 3 times negative 5, I have different signs here, so my answer is going to be, that's right, negative. So my answer here is going to be negative 15. And then down here it's going to be, right, negative 24. So here we're dividing different signs. So for the first one we have 80 divided by negative 10. That's right, it's going to be negative 8. 45 divided by negative 5. Hope you're thinking negative 9. Alright, so here we have same signs. So we know that same signs are going to produce positive answers. So negative 3 times negative 11 is going to be positive 33. Negative 7 times negative 3 is going to be positive 21. Alright, so a few more problems here. Negative 14 divided by negative 7, that's same sign, so my answer is going to be, yep, that's right, positive 2. Negative 28 divided by negative 4, that's going to be positive 7. Now we have a fraction over here, which a fraction bar just means that you're going to divide. So negative 27 divided by negative 3, same signs, we should get a positive 9. Alright, last few examples. Whenever we're multiplying three numbers by one another, we can simply just multiply from the left to the right. So negative 3 times negative 4, that's going to produce a positive 12. But a positive 12 times a negative 2, that's going to be different signs, so my answer is going to be negative 24. So you're going to have to be careful when you get a problem like this. Go ahead and try the next one. Alright, so I hope you did negative 2 times negative 5 is positive 10. And positive 10 times negative 7, I hope you got negative 70. So that concludes our first chapter review on integers. It will be posted on my video on my YouTube, on my website and my YouTube. And tomorrow in class, we will do a few more practice problems and then move on to the next chapter, which was rational numbers. Alright, take care and have a good evening.